name is Maria and I'm an ML engineer at Megaphone. Today we will talk about what difficulties can arise when you are working with cluster and what methods are available to solve them. This report will be useful for analysts and ML engineers. In a large ML team that works with big data scientists regularly face the distributed computing. They work with millions of rows of data and put machine learning models into production. I won't go into much detail about what the Hadoop ecosystem all about. Let's remember that it has four main models: Hadoop Common, HDFS, Yarn, Hadoop MapReduce. Today we will talk about configuring the Spark configuration, monitoring Spark application using Python methods, the problem of small Hadoop files for glue on HDFS, and cluster memory. Let's start with this problem. Several users on a cluster can use all the resources, which can influence the work of the others. Despite the fact that each user is limited in resources, this limit is set high enough for complex tasks. In order not to lower the limits, users should use the settings on the Spark configuration parameters. If you don't know how many resources you need for a task, then you should use the basic parameters. Here, max executors, maximum number of executors for dynamic resource allocation, executor cores, number of cores for one executor, memory, the amount of memory for one executor, memory overhead, the amount of out-of-order memory that can be allocated to the executor. At the same time, you need to check the configured dynamic resource allocation. In other words, enable dynamic resource allocation, enable data saving at the shuffle stage, and limit waiting time for one executor. In running the application, you can monitor how many cluster resources you are using. When setting the configuration, the task will consume no more than max executors multiply Spark executors cores of processors and no more than max executor multiply Spark executor memory in the worst case scenario. In order not to register the specified configuration, every time you can wrap it into internal library. So we have defined the main parameters for adjusting the load on the cluster. Now let's talk about monitoring. If you have an access to running application, you can get a report with the parameters of Spark application that you are interested in. This can be done using Python methods. You will need the subprocessor library to access Yarn and display a list of applications using the Yarn application list command. The requests library to access the Yarn Resource Manager UI, the beautiful SOAP and Ray libraries for the site parsing, and the pandas library for generating the report. This way we will get a data frame that will contain accounts, application IDs, launch URLs, and resources used. IDs and URLs are hidden on the picture. Why is this even necessary? Using this information, you can configure triggers for the specific events. For example, some apps can run without performing any tasks. You can use the date of the last completed task of the app to determine the time of its last activity. Even if the app does not perform tasks for a long time, it continues to allocate resources that someone may need. Such application must be stopped. For example, if you exist 7 days of inactivity, you can send a notification to the user or do Yarn application queue. Such events can be wrapped in a Docker and placed on the schedule in Airflow. Now let's talk about working with cluster memory. In distributed computing, data in memory is divided into partitions, which are saved as files to the cluster disk space. And it is very important to monitor this saving. In HDFS, each file is stored in 64 or 128 megabytes distributed file system block. The approximate size for storing each such object is 150 bytes. That is, a file with a size of 1 megabyte is stored with a block size of 128 megabytes. Two files with a size of 1 megabyte will be stored in 2 blocks and take up 2 times more space in the namespace, although they could fit in 1 block. Many small files will take up a lot of space on the name node. As a result, there may be the following consequences: inefficient disk space filling, slowing down the speed of completing tasks, workload increasing, performance dropping. When you are writing to Hive, a dynamically partitioned Hive table, each partition is processed in parallel and opens a new file for each new partition key. If the value of Spark SQL shuffle partitions is equal to 200 and it uses partition by in 50 target partitions, then as a result we will get 10,000 files. In order to deal with this, you need to use partitioning methods, which allow you to split data into parts. Apache Spark supports 2 types of partitions: in memory using repartition or coalesce, on the disk using partition by. Therefore, to save the tables correctly, use the following code. First, we apply repartition to the Spark data frame and change the number of files by num files partitions. Then we apply partition by if we want to increase folders to store the files. The difference between coalesce and repartition is that coalesce can only reduce the number of partitions, since coalesce redistributes existing data partitioning, and the repartition completely mixes them up and can increase or decrease the number of partitions. Before saving, you need to check the number of unique values in the partitioning column. If partitioning uses a unique key with 1,000,000 values, the name node will crash. A simple way to check uniqueness by a column is distance count. To control small files on HDFS, you can configure notification in Airflow for specific folders in the file system, for example, using the bash code. HDFS DFS count with sorting outputs with the lists of the object in the directory with their memory and number of files in descending order by the second argument. But it is quite possible that you need to correct an existing table and it is not enough just to change the saving method. In this case, you can use Spark hidden methods to implement the file gluer on HDFS. And it may seem like a simple task, but it is not true if you don't know that you need to look for hidden methods. By accessing the file system, you can count, delete, and move files. For example, view the total size of the directory in bytes, or get the total number of files in directory. If you want to change the table, you need to make a resave to the temporary folder and move files from the temporary folder to the original one. Use the copy method to move files. We talked about partitioning methods to maintain cluster stability, but it is also important to control the amount of memory in regular table saving. Add date partition during saving and clear a partition that exceeds the table storage depth using the Spark SQL query. If the tables are already saved without limiting the storage depth, you can configure automated table cleaning using the Airflow and bash script. This script outputs all objects in the folder, determines the time then the object was created, and deletes files with exceeded storage depth. Then summarize. You need to configure the Spark configuration to control the load on the cluster. You can use Python methods to monitor specific triggers on the Spark application. The problem of small files can be solved using the repartition, coalesce, and partition by. The ability to access the hidden Spark method allows you to edit existing data and implement HDFS gluing. You can monitor the memory usage on the cluster with HDFS DFS. And here you can see my contacts, and now I can answer your questions.